So 8.3. 8.3, we're going to talk about a different type of sequence. It's called geometric sequence. So in a geometric sequence, the ratio of any term to the previous term is constant. This constant ratio is called the common ratio. And it's denoted by R. So the difference between arithmetic, which we were doing last time, and geometric is geometric, we multiply to get from one term to the next. So an example of a geometric sequence would be 2, 4, 8, 16. What do you think my next term would be? 32. We're multiplying by 2 each time to get from one term to the next. So our common ratio, or R, would be 2. So for these, we're going to have a common ratio, unlike the other ones, which we had a common difference, because that was when we added each time. So for example 1, we have to tell whether each sequence is geometric. So what am I multiplying to get from one term to the next, from 6 to 12? I'm multiplying times 2. If I multiply 12 times 2, do I get 20? No. So is this geometric? No. All right, for B, what am I multiplying to get from one term to the next, from 256 to 64? I'm dividing by what? Not 1/2. I'm multiplying by 1/4. We're dividing by 4 or multiplying by 1/4. So for geometric, you're always multiplying. So if it looks like you're dividing, just whatever you're dividing by, put 1 over that number, and that'll give you the ratio. So we're multiplying by 1/4 to get from one term to the next one. So what would our common ratio be? 1/4. So is this geometric? Yes, because we have a common ratio, because all of these numbers are the same. All right, let's try again for the next page. What am I multiplying to get from 27 to 9? I'm multiplying 1/3. If I multiply 1/3 to 9, do I get 3? And if I multiply 1/3 to 3, do I get 1? If I multiply 1 by 1/3, do I get 1/3? So is this geometric? Yes. Because we have a common ratio, it is geometric. For 2, what am I multiplying to get from 2 to 6? 3. If I multiply 6 times 3, do I get 24? No. What do I have to multiply times 6 to get 24? 4. Are these the same number? So is this geometric? No. For number 3, what am I multiplying to get from -1 to 2? -2. If I multiply 2 by -2, do I get -4? If I multiply -4 by -2, do I get 8? And if I multiply 8 times -2, do I get -16? So is this geometric? Yes. Because we have a common ratio. All right, so just like we had to write rules for our arithmetic sequence, we're going to do the same thing for geometric. We just have a different formula here. So our formula is a sub n is equal to a sub 1. What's a sub 1? What was a sub 1 in the others? The first term. Times r. What do you think r is? The common ratio. So that's what we multiply to get from one number to the next. And it's r to the power of n minus 1. So n would be the number of term. And then one way to find our common ratio, so to figure out what r is, if we can't see it easily, you could always do the second term divided by the first term. So just like in arithmetic, we did the second term minus the first term to find out what we're adding each time. This time we do the second term divided by the first term to find out what we multiply each time. So let's do some examples. So our formula when we write a rule is a sub n is equal to a sub 1 times r to the power of n minus 1. So we have to write a rule. So rule just means that we need the formula for the nth term. So n is our variable when we write the formula. Then we have to find a sub 8. So let's start with our rule. For our rule, we need to figure out what a sub 1 is and what our common ratio is. So what's our first term? 5. It's the first term in the sequence. Now for our common ratio, we could do the second term divided by the first term. So it's 15 divided by 5, 3. So I'm multiplying by 3 each time to get from one number to the next. So our common ratio is 3. So let's plug those in. We have a sub n is equal to 5 times 3 to the power of n minus 1. Now if you don't put parentheses around the 3, make sure you separate it by multiplication. So you could say 5 times 3 to the power of n minus 1. You need something in between there that says that you're multiplying, because if you don't, it just looks like 53. So you just need something there. So this would be our rule. Remember, our rule just leaves n, as the variable. So this is the rule. Now to find a sub 8, what do you think I need to do? Plug in 8 to n. So I have 5 times 3 to the power of 8 minus 1. So 5 times 3 to the power of 7. You can use your calculator for this. So 3 to the power of 7 would be 2,187. And then we still have to multiply that times 5. So a sub 8 is 10,935. For these, since we're multiplying to get from one number to the next, the numbers get really big really quick. So when it asks for like the 8th term or the 10th term, it's going to be a big number. Usually, unless your ratio is a fraction. All right, let's look at B. So first thing we're going to do is write our rule. So I need to figure out what our first term is and our common ratio. So what's my first term here? 88. How can I find the common ratio? We do the second term divided by the first. So negative 44 divided by 88. What is negative 44 divided by 88? Negative 1/2. So I'm multiplying by negative 1/2 to get from one number to the next. So yes, it looks like we're dividing by 2, but when we plug it into our equation, when we need our common ratio, it's what we're multiplying. So we're multiplying by negative 1/2. So let's plug that into our formula. We have a sub n is equal to, what would come next? 88 times, what? Just 1/2? Negative 1/2 to the power of n minus 1. So be careful here, because that negative 1/2 is the number that's raised to the power. So that negative also is in that exponent there. So you just make sure you put it in parentheses. Times. So this would be our rule. For our rule, we don't plug anything into n. We just leave n as a variable. Now for a sub 8, because it asks us to find the 8th term, what would I do? So I do 88 times negative 1/2 to the power of 8 minus 1. So we have 88 times negative 1/2 to the power of 7. So this would be 88 times. Now we need to do negative 1/2 to the power of 7 in our calculator. So that would be 1 over 128 negative. So when we multiply this, when you multiply fractions, multiply the tops together, multiply the bottoms together. So it would be 88 over, negative 88 over 128. Now can I simplify this? Yeah. I think I can divide them both by 8. Yeah. So we get 11 over, negative 11 over 16. So this would be the 8th term. Now, one way to check the signs, just in case you had something go wrong in the calculator, when the signs alternate, it's easy to make a mistake. But one way to check is that our terms, the even term, so this is my second term here. So second term's negative. And the fourth term's negative. So the even terms are negative. Meaning that this is the first term, it's positive. Second, 2 is an even number. Second is negative. Third term, third's odd, so that would be positive. Fourth term, 4 is even, so it's negative. So it alternates. So the even term, the 8th is even, so the 8th term would also be negative. So you can just check because your signs are going to alternate. So that's one way to just double check your work. All right, let's look at number 4. We're doing the same thing here. It asks us for the rule and a sub 9. So let's start by finding the rule. We need to figure out what a sub 1 is and our common ratio. What's our first term? 3. What's our common ratio? 5. We're multiplying by 5 to get from one term to the next. If you didn't see that right off the bat, do the second term divided by the first. That would give you 5. So let's plug it in. We have a sub n is equal to, what comes first? 3 times what? 5 to the power of n minus 1. So this would be our rule. Now the second part of this question asks us to find a sub 9. So how do I find the 9th term? Plug in 9. So 3 times 5 to the power of 9 minus 1. So 3 times 5 to the power of 8. So I'm going to do 5 to the power of 8 in my calculator. So we get 390,625. Yep, and then times 3. So a sub 9 is equal to 1,171,875. So that would be our 9th term. Next, we're going to find the sum of a finite geometric series. So finite just means that it has an ending. So at some point, we'll find the sum of an infinite geometric series. That would mean that it has no ending. But for now, we're going to find the sum of a finite geometric series. So it has a start and an end. So for the sum, we use this formula. So it is a sub 1 times, what's a sub 1? The first term, times 1 minus r to the power of n divided by 1 minus r. What is r? The ratio, the common ratio. And what do you think n is? Number of terms. Okay, so for example 5, we have to find the sum of a geometric series. So because this looks like our geometric series formula, because it has an exponent, that tells us that it's geometric. So right off the bat, the question's going to say find the sum. Sometimes it's hard to tell whether it's geometric or arithmetic, but because this has an exponent, that makes it a geometric series, so we have to use our geometric formula. So our geometric formula for sum is S sub n is equal to a sub 1 times 1 minus r to the power of n divided by 1 minus r. Same thing on the last page. So we need to figure out what our first term is, what our common ratio is, and what the number of terms are. So to find a sub 1, we're going to take the first number here and plug it into k. So this tells us that k is equal to 1. That's the first number we start with. So I plug 1 into k. So I have 4 times 3 to the power of 1 minus 1. What's 1 minus 1? 0. What is 3 to the power of 0? 1, and 4 times 1? 4. So a sub 1 is 4. So I can plug that in to a sub 1. Now our common ratio is always going to be the number that has the exponent. So what number here has the exponent? 3. It's the number that's in parentheses here. It's always going to be that number that it's either going to be in parentheses or it has the exponent. So 3 is our common ratio. And then lastly, we just need to figure out our number of terms. So number of terms is going to be how many numbers you have from 1 to 10. So from 1 to 10, it's going to be that number on top. We have 10 terms here. So we plug that into n. So this would be our formula with everything plugged in. Be careful when plugging it all into your calculator. So just make sure you follow your order of operations. We have to start with the parentheses. In the parentheses, I'm going to start with what's on top. So I have to start with 3 to the 10th power. So 3 to the 10th power would be 59,000. I'll write it down. 1 minus 59,049 over 1 minus 3. So 1 minus 59,049 would be negative 59,048 over, and what's 1 minus 3? Negative 2. So I'm going to divide this by negative 2. So we get 29,524. And that would be all times 4. So we should get 100,000, 18, and 96. 118,096. So that would be our sum. When your ratio is a whole number, remember you're multiplying to get from one number to the next, and those 10 numbers in our sequence, we're adding them all together, so it's most likely going to be a big number. But if our ratio is a fraction, remember that means we're dividing to get from one number to the next. We're going to end up with small numbers, so it may be a small number. So just don't be afraid if you get a big number. We're going to do a couple more. So for number 7, we need to figure out our first term, our common ratio, and the number of terms. How do we find the first term? A sub 1. So I plug in 1 into k. So I have 5 to the power of 1 minus 1. So it'd be 5 to the power of 0. And what's 5 to the power of 0? 1. What would my common ratio be? Remember, common ratio is the number that has the exponent. 5. And what is my number of terms? 8. That would be the number on top, so that is 8. So let's plug it all into our formula. We have S sub n is equal to a sub 1 times 1 minus r to the power of n divided by 1 minus r. So S sub n is equal to 1 times 1 minus 5 to the power of 8 divided by 1 minus 5. What would I have to do first here? The parentheses. What in the parentheses? The exponent. So I'm going to do 1 minus 5 to the power of 8 would be 390,625. So 1 minus 390,625 would be negative 390,624 divided by, what's 1 minus 5? Negative 4. So I'm going to divide this by negative 4. We get 1 times 97,656. And 1 times that would just be 97,656. So the sum is 97,656. All right, let's do number 8. So what's my first term? How do I find the first term? Plug in 1. So I'm going to plug in 1 into the I. So I have 6 times negative 2 to the power of 1 minus 1. What do I get when I evaluate this? So 6 times negative 2 to the power of 0. What's negative 2 to the power of 0? And 6 times 1? 6. Now let's find our ratio. What would our ratio be here? So the ratio is the number that has the exponent. Negative 2. And then we need to find our number of terms. What would my number of terms be? 12. So let's plug it all in. So S sub n is equal to a sub 1 times 1 minus r to the power of n divided by 1 minus r. So be careful when r is negative. Doing the same thing, but you just got to be extra careful with your signs. So first thing I want to do is the parentheses. So I'm going to do the top of the parentheses. So negative 2 to the power of 12. That would be 1 minus positive 4,096 over 1 minus negative 2. So on top, we get 1 minus that. So 1 minus 4,096 would be negative 4,095. On the bottom, what is 1 minus negative 2? Awesome, this turns into a plus, so it would be 3. So then I have negative 4,095 divided by 3 gives us negative 1,365. And then last step is we multiply that times 6. So it would be negative 8,190. So after plugging it in, a lot of it is just being careful with the calculator. Make sure you know how to use your calculator. Make sure you follow PEMDAS. So I would definitely suggest practicing the homework with whatever calculator you're going to use for the test. That way you know how to use your own calculator. Okay, let's do number 9. You need to figure out what our first term is, common ratio, and number of terms. How How do I find the first term? Plug in 1. So I have negative 16 times 0.5 to the power of 1 minus 1. What's 0.5 to the power of 0? 1, and 1 times negative 16? Negative 16. What would our common ratio be here? 0.5. Perfect. It's a number that has the exponent, so that would be 0.5. What's n? How many terms are we looking at? 7. So let's plug everything into our formula. The sum is going to be negative 16 times 1 minus 0.5 to the power of 7 over 1 minus 0.5. So here, we're going to do the same order of operations. We're going to do the exponent first. So 0.5 to the power of 7 is going to be 0.007812. Keep it in your calculator so you can get a number that's as exact as possible. So I'm going to do 1 minus 0.007812. So we get 0.9921875 divided by, what's 1 minus 0.5? 1 minus a half is just 0.5. So we're going to take this number, divide it by 0.5. We get 1.98435. And then what's the last step? Multiply by negative 16. So we get negative 31.75. So again, keep it in your calculator for all the steps in between. If you don't keep it in your calculator, make sure you write down all the decimal places to get a number that's as exact as possible. So a lot of people just like to write down a few decimal places, but don't round in your work. You round at the end. This number isn't even round. This is exact because I kept all of the decimal places in every step. So keep all the decimal places in each step to get a number that is exact.